Hey guys, welcome to the live stream tonight. This is our first live stream since we've started talking about fractions. And I'm just feeling really good this week because you guys know I love fractions. So I'm excited to get to talk about fractions after school has ended. So I'm excited. Hopefully you guys are enjoying doing some fractions on homework because I know that you guys all love fractions. So tonight we'll hopefully clear up some things about fractions. If you're confused about anything, feel free to ask any questions that you may have. I will answer any question about fractions or decimals or anything on homework or anything in general that you're worried about that you may have. So we will get started without any further ado. So we'll start on the beginning of homework. So today in class we were talking about taking a fraction and making it into a decimal. Now, one thing we know about fractions is that the denominator tells us how many pieces that a fraction is split into. So we know that the larger the denominator, the smaller the pieces get because the more pieces that we're splitting something into. So we looked at these fractions here. So the very first one says 9/10. Notice when we have a 10 in the denominator, that is one of our decimal place values. Remember we were talking about the tenths, the hundredths place, and the thousandths place, with the thousandths place being the smallest because it's split into 1,000 pieces. Well, this first one here is already split up into tenths. So because we have a decimal place value that's tenths, we would read this number as 9/10. So we can actually just write that down as a decimal. So 9/10 as a decimal would just be 9/10. So that one was kind of easy. The second one says 3/5. Now, notice here, we don't have a 10, 100, 1,000. It could even go further at 10,000, 100,000, a million. We don't have one of those things in the denominator of our fraction because here we're split up into fifths. So what we can do is we can actually change the denominator of that fraction as long as we also change the numerator. So we're actually going to take this 5 and we're going to make it into a 10. One way we're going to do that is we're going to take that 5 and we're going to multiply by 2. And remember, whatever we do to the bottom of the fraction, we must do to the top of the fraction. So we're going to multiply the top of the fraction by 2 as well. So we have 3/5, and if we multiply both of those by 2, 3/5 is the same exact thing as 6/10. So now that we have a 10 in our denominator, we can easily write that as a decimal. So 3/5 is equal to 6/10. All right, moving on. 3/4. Now, we know that 3/4 is one of the benchmark fractions that we've talked about on our number line, and we'll be talking about that later when we get to our number line. But one thing we can do with 3/4 is we can take 3/4 and we can't split it into 10 pieces, but we can split it into 100 pieces. So what we're going to do is we're going to take this 4 and we're going to split it into 100. So I'm going to multiply the bottom. If you think of quarters, because remember a fourth is 1/4, so 3/4 would be 3/4. So we're going to multiply both of these by 25. If we multiply both of those by 25, 4 times 25 is going to give us our 100 that we need, so 100. And 3 times 25, think of how much money you would have if you had 3/4. 25, 25, and 25 is going to give us 75. So 3/4 is equal to 75 hundredths is what it would look like as our decimal. Notice in the next one we have 19 thousandths. This one is already split up into thousandths for us, so we know that we don't really have to do anything to that because 19 thousandths is one of our decimal place values. So we're just going to write that as 19 thousandths, which is that. All right, the next one was one of the ones we talked about today that we were like, oh, that's a little bit tougher. Because eighths can't be split into tenths. It can't be split into hundredths. So it has to be split into thousandths. So that was that one I was like, you're kind of going to have to remember this number to make it a little bit easier. It's something that you're going to have to kind of memorize. So 5/8, remember, we can split into thousandths. But you're thinking in your head, what do I multiply 8 by? in order to get 1,000. Well, in order to go from 8 to 1,000, you have to multiply that 8 by 125. And remember, whatever you do to the bottom, you have to do to the same to the top. So we're going to multiply the top also by 125. Now, I might go over to the side and do 125 times 5. But I know that 125 times 5 is 625. So I know then that 5/8 is 625 thousandths. Now, if you're questioning yourself and thinking, well, does that make any sense? Well, you know that 5/8 is just a little bigger than half, because 4/8 would be half, and 625 thousandths is also a little bigger than half. So at least I know my answer makes sense. Okay, the next one we have 1/2. This one might be one that you just memorize. We know that 1/2 is 5/10, and I'm not gonna take the time to make our denominator there, but we could split that up into 10 pieces by multiplying each the top and the bottom by 5. You could do that as well. All right, so 1/3. If we have 1/3, this one's a little bit different, honestly, because the thing about the denominator of 3, you can't split it into 100. We can't split it into 10. We can't split it into 1,000. Even 10,000 or 100,000 or a million won't split into any of those. 1/3 is a decimal that we call a non-terminating decimal. That means it's a decimal that's going to go on forever. So something that we talked a little bit about today, and we'll continue to talk about it, is that this sign in the middle, this bar in the middle, actually is kind of the same as a division symbol. So we could read that as 1/3, or we could read it as 1 divided by 3. So if we actually took 1, I'm going to do it to the side over here. If we took 1 and divided it by 3, and we'll talk more about this tomorrow, so I'm not going to go too deeply into it. But if we took 1 divided by 3, we would figure out that we would get a repeating decimal. 1/3 is going to repeat forever. It's going to be 0.33333333333 forever 3's. So one way we can write that is we can write 0.33, and because the 3's repeat, we'll put a little bar over it like that. That just shows that it goes on forever. All right, and the last one, 7/50ths. If we multiply the bottom by 2 and we multiply the top by 2, we'll get hundredths, which will give us 14 hundredths, which looks like this. 14 hundredths. All right, moving on to the next section. I'm just going to really quickly go through this section just because for time. So we have 9/10ths and we have 99 hundredths. One thing I'm going to suggest is we talked about making common denominators. Make common denominators between these two numbers. So if you look at your denominators, you have a 10 and you have 100. I always suggest trying to make one of the numbers into the other. So we can make 10 into 100. So your common denominator is going to be 100. Once you make common denominators there, you're not going to have any trouble finding 5 numbers in between. So I'm just going to suggest, we're going to kind of skip over that one, but I'm going to kind of suggest that you just make common denominators there. All right, the reason I wanted to skip over that is because I want to have more time to talk about our fraction number line. So we have all of these fractions. I have 1, 2, 3, 4, 5, 6, 7 different fractions. Now, these fractions are ones that we've been talking about in class. And we can use a lot of logic to order these fractions, but at some point we're also going to have to use some of the skills that we've talked about in class too. So I'm going to go through first, and I'm just going to pick out the fractions that are smaller than 1/2. So I'm just going to go through and circle the fractions that I noticed that are smaller than 1/2. So I know that 1/5 is going to be smaller than 1/2. It's split into 5 pieces, and we only have one of those pieces. I know that 3/10 is going to be smaller than half. Half of 10 is 5, and 3 is smaller than 5. And I know that 1/8 is going to be smaller than half because I'm splitting something into 8 pieces. I only have 1. 4 of those pieces would be half. So I'm kind of start my number line off by saying 0 would go at the beginning, and 1 would go at the end, because none of my numbers here are larger than 1 whole. So I'm going to start at 0 and I'm going to end at 1. And right in the center of my number line here is going to be 1/2. Now I know these 3 numbers that I just circled in red are smaller than half, so I know that they're going to be on this side of my number line, and the rest of my numbers are going to be over here. So I'm going to start with the ones that are smaller. So I'm going to start with the one that I know where it's going to go. So I have 1/8. One thing I'm going to do is I'm going to put a mark here, because remember that's one of our benchmark fractions. That's 1/4. Well, I know that the number 1/8 is smaller than 1/4 because it's split into more pieces. Therefore, the pieces are smaller. And actually, 1/8 is exactly half of 1/4. If you would take out your fraction circles, you would notice that if you take 1/4 and cut it in half, that's the same as 1/8. So what I'm going to do is I'm going to put 1/8 at exactly the halfway point between 0 and 1/4. So that's one of the numbers we have down. Now, 3/10, which is here, I'm going to kind of think of in a couple ways. We talked about today in class how you could make 3/10 into a decimal. So that's actually what I'm going to do. I'm going to take 3/10, and I know that as a decimal, 3/10 would look like that. So I know that 1/4 is equal to 25/100. 3/10 would be slightly bigger than that. Pretty close, but slightly bigger. So I'm going to put 3/10 just right beside that. And I'm done with 2. Now, 1/5 I know is bigger than 1/8 because it only has one piece, but it's split into fewer pieces, so the pieces are going to be a little bit bigger. But it's a little bit smaller than 1/4 because 1/4 is only split into 4 pieces, so the pieces are just going to be a tiny bit bigger. So I know that 1/5 is going to go between 1/8 and 1/4. Now I have 4 numbers left. First thing I'm going to look for is I'm going to ask myself, are any of these numbers close to being 1 whole? A lot of people will point out 2/3, but keep in mind that 2/3 is only missing 1 piece from being a whole, but it's missing a whole third, which is a really big piece. So it's actually not as close to a whole as it seems. On the other hand, 9/10 is also only missing 1 piece, but it's missing one really small piece. So if the number is missing a small piece, then it's closer to a whole. So I'm going to start off with putting 9/10 way over here because I know that 9/10 is really super close to a whole. So I'm left with only 3 numbers. Now, here's what I would suggest with these 3 numbers. All 3 of these numbers are very close in size. So what I would do is I would take these 3 numbers, and one thing we've done in class is we talked about making common denominators. It might be a good idea to make a common denominator between all 3 of these numbers. Now, remember what we mean by common denominators, making all the denominators the same. So remember in class we talked about writing down the multiples of each of these numbers and trying to find a denominator that's the same for each. So I would write down multiples of 3, multiples of 12, and multiples of 8, and I would try to see if I could find a place where all the denominators are the same. So I'm going to challenge you to do that. Now, I'm going to tell you that all 3 of those numbers are definitely smaller than 9/10, and they're all bigger than half. So they're all going to fall in this area right here. I'm just going to leave it up to you guys to try to figure out where they fall. Common denominators would be a good way to check that, though, because those numbers are all very close in size. So try that out. All right, moving on to the next section. We'll try to go through this section a little bit faster. So we have our distributive property. Keep in mind that when we're doing the distributive property, we're splitting a number up into small pieces, and we're multiplying by those small pieces with the other number. Now, we're just going to go over, I'm not going to go over all of these with you, I'm just going to pick out a few. So let's go over the first one. So in the first one, you see 4, remember when we don't have a sign but we have parentheses, that means multiplied. So you see 4 times 3 plus 11. The number we split up into 3 plus 11 was 14. So we broke the number 14 down into 3 plus 11. So since 3 plus 11 is the same as 14, what we're going to do is we're going to multiply each of those numbers by 4. So you'll notice that if you multiply 4 times 3, that is 12. And if you multiply 4 times 11, that is 44. Now what we want to do is we want to add those two numbers together. And you'll notice that you see an addition symbol right in between. So that is an example of the distributive property. So I would circle that one. Now, the next couple you see on there, you'll notice they don't really look anything like the distributive property. The second one would be an example of the commutative property. That just means that the order is changing. So 3 times 4 is 4 times 3. That's a true statement, but it's not an example of the distributive property. Keep that in mind. The other ones I want to look at are, let's look at the bottom one here. So we see 17 times 10 plus 1. So we broke down the number 11 into 10 times 1. Keep in mind, we chose numbers that were easy to multiply by. So what we're going to do is we're going to multiply these two numbers, 10 and 1, each by 17. So first we're going to multiply 17 times 10, which you see here. And then we're going to multiply 17 times 1, which you see here. And we want to add those two together. So again, that would be an example of the distributive property. I want to show you one more because it's one that throws a lot of people off. And it is the second one from the top on this side, this one right here. So on that one you see 18 times 10 plus 1, but notice the difference between this one and the last one. On this one, instead of seeing a multiplication sign here, you see addition signs. Little things like that show that it's not the distributive property. So really look out for your symbols and think about what you're doing when you're splitting up those numbers. So that's something I would suggest. All right, let's move on to the last question. Let me just check really fast to make sure we don't have any questions. All right. Remember, if you have anything specific that you want to ask about, ask it on either YouTube or on Google Classroom. I'm trying to check both of those. All right, and the very last question says, Jorge is one of the greatest Lego builders that the world has ever seen. Just last week, he was invited to France by President Macron to build an exact replica of the Eiffel Tower. To build, Jorge was given a budget of $10,000. If he spends $5,477.22 on Legos, $342.60 on McDonald's cheeseburgers on his breaks, and the rest of the money on copies of the Lego Movie on Blu-ray, how much money did he spend on the copies of the Lego Movie? So one thing I notice here is that we have a total of, $10,000. So I know that he couldn't have spent more than that. Now, I know that he spent this much on Legos, $5,477.22, and he spent $342.60 on McDonald's. Whatever is left must be what he spent on the copies of the movie on Blu-ray. So when I see that word left, I'm thinking subtraction. Now, in order to figure out what he has left, first we need to figure out, well, how much did he spend on the other things? So if I were working this problem, I would add together $5,477.22, and I would add that together with $342.60. Now, if I add those two numbers together, that's going to give me a total of what he spent combined between the Lego movie, between the Legos and the hamburgers. So whatever is left must be from the movie. So now that I know what he spent combined between these two, I'm going to take my answer to this and I'm going to subtract it from $10,000. Now keep in mind, $10,000 is going to be the larger number, so that's going to go on top in your subtraction problem. Remember that when we're subtracting, we can put, for instance, 10,000, and if we wanted to, we can add on a decimal and 2 zeros on the bottom, just like that. So you're going to add these two numbers together here, and then you're going to subtract your answer from 10,000, whatever you get for your answer. And that should tell us what is left to buy the Lego movie. So I think we have just about gone over everything. Keep in mind, we are going to be working on in class a little bit more on changing fractions into decimals over the next couple days. And then we're really going to get into incorporating decimals and fractions and comparing them to one another. And since we've already talked so much about decimals, and now we've talked a lot about fractions in the last 2 days, I don't think you're going to have too much trouble with that, because you're going to see that they're very, very similar in a lot of different ways. Now, one thing before I leave, we went for dinner and got some my favorite food, Costco pizza. And you know, I've been telling you guys the last couple days about how fractions are so much like pizza. So I just want to prove that to you. Keep in mind, here's the pizza. Keep in mind that it is split, in this case, I was counting downstairs, it's split into 12 different pieces. Now keep in mind, if I only split it right down the center, the pieces would be really big. That would be like half of the pizza. In this case, though, it's split into 12 different pieces, and you'll see here that one piece is pretty big for pizza, but it doesn't take up that much of the whole pizza, because it's only, this would be 1/12 of the whole pizza. Now, if I ask you what I had left, this would be like 11/12 of a pizza. And I've asked you guys in class, well, what would 11/12 be close to? Well, 11/12 is pretty close to the whole pizza, because in order to get to a whole, you're only missing 1/12, or one pretty small piece of pizza. Now keep in mind too, that if I asked you, well, how much would half of the pizza be? Well, you would need 1, 2, 3, 4, 5, 6 pieces to be exactly half of the pizza. So fractions, guys, are so much like food. They're so much like, you know, anytime we go to the store and shop and deal with money, it's dealing with fractions and decimals. So we have to constantly be thinking about these things, and it was a part of my dinner tonight. So I hope you guys enjoyed, and I hope you guys feel pretty confident about your homework. If you have any other questions, please come and ask in the morning. Please ask in class, and I'll do what I can to help you out. Hope you guys have a really nice evening, and I'll see you all tomorrow at school.